So this is our, really just the beginning of our 3D shop. One of our engineers had asked if we could just go with a simple 3D printer, just to do some basic plastic. And so we put this thing together. These are some of the components that we are prototyping. These actually reflect the shoes that we have on our machines. So typically they're made out of hardened steel. And we are experimenting to see if different composite materials can withstand the wear and tear. That significantly reduce the price. Certainly the weight, the ergonomics, because this thing you can barely pick up when it's the hardened steel. But we're actually going to be taking this to the tire show just to try to promote some of our additive manufacturing capability. And then when we're talking about additive manufacturing for the company, then we're also looking at saying we are the innovation leaders of machinery to advance manufacturing capability. And you look at the growth of that side of the industry, should we also be looking at 3D machines, to actually maybe manufacture? So we're actually looking at that right now. Another aspect of our business, as we mentioned, on the composite side. So you saw those metal layers with the flexible pipe. The industry is looking at and exploring the possibility of replacing at least one of those layers with composite material. And it's got to have certain characteristics for a coefficient of friction, of heat, has to have that insulation properties, because the material coming out of the ocean floor is very hot and you need to keep it hot as it gets to the surface. So we're actually exploring that as well. We've actually made a partnership with a company out of Albany that is into those type of polymers, the composite applications for laser heat treat and infrared, and then you onboard that equipment on our rotating machinery. So that's just showing you some of the things that we're trying to do to keep our industry ahead of the curve. But the future state for this would be trying to get into metal printing, because then we have all kind of applications, obviously, as a machine shop, to look at the metal printing applications. And it would certainly help us prototype faster. Because that's typically what we're trying to do here for the purposes of manufacturing integration. Okay, so we'll just go out here. All right, so this is a new water jet machine, and it's just a capital investment that we've made this past year along with some other CNC machines, and has the ability to program a whole slew of work, and you basically walk away and it prints it out. We're using one of our operators over here to basically manage both sides. So it's a cost savings, but it certainly increases our ability to manufacture in-house and also to bring more work in rather than outsource it. So that's the whole idea here. So this is just a sample of something now it's starting to rust, but I mean the complexity, because it's a 5-dimensional, and getting different angles.
So it's starting with a solid piece, and
solid piece, and it cuts it all out with the stone that we use is like a garnet stone. You see it in that cylinder over there. So it's very fine particles, and it's just shooting it into the water. When they delivered the machine, we actually saw some safety concerns with the machine. So we started labeling, we started adding restrictions, some of the guarding, because I was surprised. And they have veins inside that if any operator put their hand in, they're very, very sharp. And so we try to restrict what they can do near that machine. But yeah, so this is just showing some of the investment that we're making, and again, trying to bring more work in-house. So then we'll walk down here. Cool. So really the material flow, raw material comes through here. We have a weld shop in the back, and they do some of the basic welding, and then that flows into our machine shop where we have the full CNC capability.